Here in example 4.9, we are asked to draw the shear and moment diagram for each of the beams shown in the figure. So, let's try the first. Ayan. So, for the first beam, as you can see here, we have a cantilever beam. No? Sa cantilever beam, ang gagawin lang natin first is gagawa tayo ng reference line, no? Para sa pagdodrawing natin ng ating shear and moment diagram. Okay, so ang unang gagawin natin dito is to determine first ano ba ang mga reactions na meron tayo dito. As you can see here, we have the cantilever beam. Since cantilever beam ito, so we are expecting to have shear reactions kasi po dito, as you can see at this point, no, pangalanan natin itong point A. Dito sa point A, meron tayong tatlong reactions kasi yan ay fixed direction. So we have the AY, it is the vertical reaction. We have the AX, or the horizontal reaction. But as you can see, wala tayong load na horizontal, so this would be equal to 0. And of course, we will be having here a moment at point A. So inassume natin siya na counterclockwise. So ang gagawin natin ay isosolve muna natin yung value ng AY at saka ng moment at A. So in order for us to solve for the value of the AY, what we are going to do is to assume summation of the forces vertical, and assuming that we have the direction upward as positive, and this would be equal to 0. So as you can see here, our AY, we assume that AY is directed upward. So we have your AY, and then that's positive kasi this is upward, and our P here is downward, so we have minus P is equal to 0. So we can say that the AY is just equal to P. No? So this is our answer for the reaction of the AY. Since positive ang lumabas na sagot, meaning tama yung assumption natin na si AY is directed upward, so this is directed upward. So it's P directed upward. Okay? So if we are going to summate moment at point A is equal to 0, taking the clockwise direction as positive, then ang magki-create ng moment, of course, ay itong P. Hindi magki-create ng moment yung AX kasi 0 nga siya. Hindi rin magki-create ng moment yung AY kasi nga tatama siya dun sa point A. So we have here the moment at A. We assume this as counterclockwise, so meaning that is assumed as negative moment. So we have negative moment in A. And this P here is clockwise. So kung bakit siya clockwise, no? If you remember kung yung sinabi ko na tuslok-tuslok system, no? Kung ito yung beam, no? Dito tayo nagmo-moment sa point A, i-fix mo siya dyan, no? And kung ito yung ball pen, let's say this is a ball pen, yung ball pen mo, tusukin mo siya pababa kasi po yung P is pababa. So the tendency siya ay ikot in this direction. So meaning, the force P will create a clockwise rotation with respect to point A. So since clockwise siya, that would create a positive moment. And the moment to be created is the force multiplied by the distance, perpendicular, no, to the force. So we have here plus PL is equal to 0. So we have the moment at A is equal to PL. Since it is positive, meaning the assumption for the moment at A, which is counterclockwise, is correct. So meaning this is counterclockwise. And this is the value of the moment at point A. Ngayon, it's time for us to draw the shear and moment diagram. So, for the shear diagram, what will create the shear is no? The reaction at point A, the vertical reaction, no? Yun yung mag-create ng shear. And that has the magnitude of P upward. So, meaning dito, galing tayo dito sa 0, since this is 0, aakyat tayo sa magnitude na P. And as you can see here, wala naman tayong forces galing ng point A papuntang point B. So, ito ay magiging constant lang, tuloy-tuloy lang siya hanggang dito. Pag natin sa point B, we have the force P downward, then this would be downward, and that would make our shear diagram 0. So, dapat po ay magsasara or magko-close yung ating shear and moment diagram para ma-consider natin yung solution natin. Correct. Kapag po hindi natin napasara yung shear and moment diagram natin, you have to assess baka mayroong problema o saan ka nagkamali, bakit hindi mo siya napasara. Okay? So, next. For the moment diagram, as you can see here, we have the moment of A, which is counterclockwise. So, meaning, yun yung magdadala sa moment diagram natin into negative value. At ano yung magnitude ng moment in A? That is PL. So, ibig sabihin, bababa tayo, since this is counterclockwise, no? Bababa tayo, and it would be negative PL. Okay? And as you can see here, we have to consider this area. Papangalanan ko siyang area 1. Kukumputin natin yung area 1 kasi po siya yung i-add natin dito sa moment natin. So, computing for the value of the area 1, we have area 1 is equal to, since rectangle lang ito, we have the magnitude of T and the length of L. So, the area 1 is equal to PL. And as you can see, we have here the moment at point B. Ang moment natin sa point na to is just equal to the negative PL. Ito yon, yung moment natin at point A. And ipa-plus natin yung area 1. Bakit po plus? Kasi po area 1 is positive because it is above this line, no? 0. Since positive yung area ng ating shear diagram. So, plus area 1, which is PL. So, this would give us the moment at point B equal to 0. So, napasara na natin ang ating moment diagram. So, since this is a horizontal line, ibig sabihin, tayo ay merong 0 degree dyan, no? 0 degree yung ating equation para dito kung tayo ay gumagamit ng what do you call this? Gumagamit tayo ng shear and moment fraction. So, pagdating dito, n plus 1, kasi as you can see, this is area, di ba? Area yan. So, ibig sabihin, yung area yung gagamitin natin para makompute natin itong moment diagram, we do the integral calculus, nag-integrate po tayo dyan. So, kapag sa integral calculus, kung meron po tayong x raised to 0, kasi po, yan ay 0 degree. So, pag nag-integrate po tayo dyan, yan ay pupunta ng, so x is equal to 0 is equal to 0, right? No. X is equal to 0 is equal to 1 because any number raised to 0 is 1. No? This is equal to 1. And if we are going to integrate that would give us x. No? Raised to 1. Bakit po? Kasi ang nangyari dito sa totoong buhay, we have the n plus 1 over n plus 1, diba? Doon sa ating exponent. So, that would be x raised to 1. So, ibig sabihin, kung ito ay 0 degree, pagdating natin sa moment diagram, that would be degree 1 equation. And the degree 1 equation is a linear equation. No? Equation po ito ng line, degree 1. So, 0, always plus 1 tayo, degree 1. And, kukulayan natin. So, ito na yung ating moment diagram para dito. No? So, yun lang naman yung instruction sa atin. Sabi sa problem. Sabi lang naman sa problem is to draw the shear and moment diagram for the beam. So, etong mga to, as you can see, etong mga to ay pwede nating kunan ng mga information. Kasi po, pag nagdo-drawing tayo ng shear and moment diagram, hindi tayo nag-i-end doon. Let's say, pagdating natin sa exam, may mga tanong tayo na sasagutin. Okay. So, sabi dito na, what is the value of the maximum moment? Yun ang sasagutin mo. No? So, So the value of the maximum moment is equal to negative PL. That's your answer. And what is the value of the maximum shear? Your answer here is P. So yun yung mga basic na questions na pwede nating masagot gamit yung ating diagram. So, importante po ang ating shear and moment diagram para masagot natin kung ano yung hinahanap sa problem. Dahil ang bawat problem ay hindi lang nagtatapos doon sa shear and moment diagram because you have follow-up questions to answer. Okay, let's try the second one. Ayan. So we have here the second figure. As you can see in the second figure, so first, ang gagawin natin is establish ano yung mga reactions natin. Since this is a cantilever beam pa rin, so cantilever beam, we have 3 reactions to the support since this is fixed. So kung ito ay point A, we have here AY, we have here AX, and we have here the moment at A. So if we are going to summate forces vertical equal to 0, taking the upper direction as positive, then we could say that AY upward is equal to 0. Diba? Wala naman tayong vertical forces maliban kay AY. And if we are going to summate forces horizontal is equal to 0, taking the direction to the right as positive, then we can say that ang nakikita natin dito, we assume that AX is directed to the left, so negative siya. Pero wala rin tayo nakikita horizontal forces. So meaning, AX is also equal to 0. And if we are going to summate moments at point A is equal to 0, taking the clockwise direction as positive, we assume that our moment at A is directed counterclockwise, meaning that is negative and A. And this MO here is directed also counterclockwise. So we have here minus MO. M sub O is equal to 0. Yan. So moment at A is equal to negative of moment at O. No? So negative ang naging sagot natin. So, since negative yung naging sagot natin, ibig sabihin, mali yung assumption natin. Inassume kasi natin ang moment at A is directed counterclockwise. So, since negative yung lumabas na sagot, then kukontrahin lang po natin yan. So, we could say that the moment at A is equal to the value of the moment at O, and it is not counterclockwise, it is clockwise. Yan. Kukontrahin lang natin yung ating assumption. Wala naman tayong problema sa assumption. Diba nga, sabi ko, okay ra mag-assume, pero di mag-expect. Okay. So, di-drawing na natin yung shear and moment diagram natin. So, we have here the shear diagram, and we have here the moment diagram. Okay. So, anong meron? Kung titingnan natin sa shear diagram, wala tayong shear force because AY is equal to 0. So, meaning, ang magiging diagram mo dito ay dun lang siya sa 0. No? Ito lang. 0 lang lahat. Hanggang makarating sa dulo, 0 lang lahat. Okay? So, for the moment diagram naman, as you can see here, moment at A clockwise, so meaning that is positive. Yan. So, dito yan siya. That's the value of the MO because that's equal to M sub O. Upward. Tapos, nakikita natin, wala naman tayo nakikitang node simula sa point A, papunta dito ng point B. So, diretso lang. This is just constant. And as you can see here, we have the moment at O, which is counterclockwise, meaning this is negative moment. So, ang negative MO ay i-close niya yung MO, and that will be equal to 0. So, meaning, this would be our moment diagram. So, meron lang tayong constant na moment simula sa point A hanggang point B. And wala tayong value na shear. No? So, this is the figure for no? And ano ko siya ha, i-note ko na this diagram here is positive kasi po nasa positive field siya. Okay? So this is the shear and moment diagram for the second figure. Now, pupunta tayo ng pangatlong figure. Ayan. So we have here a cantilever beam with a load W sub O and uniformly distributed siya all throughout the span. So, first, establish muna natin yung ating reaction since cantilever na siya, tapos fixed yung connection yun dito. So, we have three reactions here. We have AY, we have AX, and of course, we have the moment at point A. Now, we will solve for the resultant of the uniformly distributed load. The resultant here is acting half of the midspan, or nasa midspan, half of the length. That's L over 2, kalahati ng L. Doon mag-act yung kanyang centroid. So, ibig sabihin doon yung kanyang resultant. So, this is just the area of the rectangle with the length of L and the height of WO. So, ibig sabihin, meron tayong dito WOL. Okay. So, kakaroon tayo ng summation of forces horizontal is equal to 0, taking the direction to the right is positive. And as you can see here, si AX ay wala namang kalaban, that is equal to 0. Summation of forces vertical is equal to 0, taking the upward direction as positive. No? And from here, we have AY assumed upward, that's positive, minus yung resultant ng ating load, which is WOL. And wala na, dalawa lang naman sila. This is equal to 0. So meaning we have AY is equal to WOL. And that's positive. So meaning tama yung assumption natin na AY is directed upward. So this is our answer for the reaction AY. And next, we are going to summate moment at point A is equal to 0, taking the clockwise direction as positive. So we assume that the moment at A is counterclockwise, so that's negative at A. And hindi naman mag-create ng moment si AX at si AY kasi nga po tatama sila dyan. Ang mag-create ng moment ay itong si WOL. No? So, that would create a clockwise rotation, tapos this L over 2 is the moment arm. So, that's positive. We have here plus WOL, and the distance is L over 2. This is equal to 0. So, we have here the moment at A is equal to, that would be, lipat ko na sa kabila ha, so that's WOL square over 2. So, that's the value of the moment. And as you can see here, we have positive, no? Positive answer. So, ibig sabihin tama yung assumption natin na siya ay counterclockwise. So, we have here counterclockwise rotation. So, this is the value of the moment at A. WOL square over 2. So, kapag nakakakita kayo ng ganitong mga problems, no? Actually, ito yung ginagawa natin ay the same na rin ito siya sa ginagawa, no? Nung derivation ng mga formula for the maximum moment, formula for the maximum shear. Kasi po, sa ganitong scenario, may makikita kayo kasi sa mga libro na kapag ganitong scenario, ito yung formula natin for the moment, ito yung formula natin for the shear, no? Ngayon, kung meron kang given, let's say, ang WO is 12 kN per meter, tapos yung length natin is 3 meters, you are just going to substitute the value of the WO here and the value of the L here, tapos may moment ka na agad, no? Using the formula. Itong mga to na palabas natin ay mga formula na sila. So, we have here our shear and moment diagram. And for the shear diagram, so start with the shear diagram. Meron tayong WOL upward. So, aakyat tayo ng WOL, magnitude na WOL. So, this is WOL. Yun yung kanyang magnitude. Ngayon, since meron tayong load, no, yung area natin dito, area 1, actually that is the resultant of the load. area 1. So, ang gagawin natin, itong shear natin na WOL, maminusan lang natin ang area 1 which is WOL. WOL minus WOL is equal to 0. So, this is degree 0 here, meaning dito po ay magkakaroon tayo ng linear equation or degree 1. Yan. Tapos, ito na yung ating shear diagram. Ayan. Ngayon, pagdating naman natin sa moment diagram natin, as you can see here, meron kasi tayong negative moment. So, mag-uumpisa tayo kay moment at A. The moment at A is WOL square over 2. So, this portion here is negative W sub O L square over 2. No? Pagkatapos, kung makikita natin dito, kikita natin, meron tayong degree 1. May degree 1 tayo, so we are expecting na dito ay degree 2 na yung ating equation. But we have the problem. Ano yung problem natin? Ang problem po natin, paano natin i-connect itong moment natin na to kasi meron tayong dalawang scenario. Pwedeng i-connect natin siya using the parabola na concave downward or parabola na concave upward. So, which is which? Kaya po, i-apply natin yung ginagamit natin na dYIX. Ano si dYIX? dYIX. If it is decreasing, you have to bend the y-axis. If it is increasing, you have to bend the x-axis. Okay. So, kung titingnan po natin dito, etong ating shear diagram, galing ng WOL, siya ay naging 0. No? So, galing dito, habang siya ay pumupunta sa kanan, lumiliit ng lumiliit yung shear. So, meaning, our shear is decreasing. So, since decreasing yung shear natin, ay dito tayo, ito yung mag-go-burn. So, we have here, if it is decreasing, you have to bend the y-axis. No? Sino si y-axis at sino si x-axis. Okay. This is our first point. From the left tayo ha. This is our first point and this is our second point. Sila yung dalawang points na yan, yung pagtatagpuin natin. Ngayon, kung sino yung first point, siya ngayon yung nagmamay-ari ng axis, no? X-axis at y-axis. Ayan, no? Ngayon, if we are going to bend the y-axis, i-bend natin itong si y-axis, ito po yung scenario natin. Dinala natin si y-axis doon. Yan, ito yan. Pag nag-bend ka ng y-axis. Pero, kapag ito naman, ang scenario natin, ito yung x-axis, ito yung y. Nasa quadrant 1 kasi yung point na to eh. Kapag yung x-axis yung binend mo papunta doon, so ito yung bending niya, ito naman yung diagram na mabubuo. Ayan. So, since tayo ay magbe-bend ng y-axis, so meaning, ito dapat yung magiging itsura ng ating moment diagram. So, our moment diagram here is this. Galing dito, papunta doon. Pero we have to prove na ito ba ay nagsara nga bang talaga. So, since this is area 1, we are going to compute now for the value of the area 2. So, as you can see here, we have to compute area 2. Ano yung area 2? Yung area 2 natin is just the area of the triangle. 1/2 multiply by the base. Ang base po natin, ito yung length. And yung height is the WL, no? W sub O times L. So, we have here our area 2 is equal to WO L squared over 2. Since our area 2 is just equal to the moment at A, no? This is negative. Etong area 2 natin is positive area. So, negative plus positive, that would be equal to 0. So, magsasara na siya doon. Then, i-close na natin. Ito yung gagamitin natin kasi po, ito yung dy. Ito naman ang scenario na to. Ito kasi ay ix. So, ito na siya. Yan. And, this curve here is degree 2. No? And this would be our moment diagram. Okay, so kung titingnan natin dito, ang moment diagram natin dito is a negative. Yan. Okay, so last figure. Okay, so for the last figure, we have here reaction. Since cantilever ito, this is fixed. So we have here AY, we have here AX, and of course, we have here the moment at A. And this is a triangle. So since triangle siya, so magkakaroon tayo ng resultant located at 1/3 of the length galing dito sa 90-degree na side, and 2/3 naman siya doon sa kabilang side. No? Nandun yung location ng center natin. And this area here is the area of the triangle that is 1/2. The base is L and the height is W sub O. So meaning this is 1/2 W sub O L. Okay. So we have to summate forces horizontal is equal to 0, taking the direction to the right is positive. So with this, our AX is equal to 0. And if we are going to summate forces vertical is equal to 0, taking the upward direction as positive, then what we have here is our AY, our resultant, no? The resultant of the node, which is the W sub OL over 2. And this is equal to 0 since dalawa lang naman sila. So our AY is equal to W sub OL over 2. And since we have here the positive reaction, so meaning this is directed upward because we assume that it is directed upward, so tama yung ating assumption. And for the moment, if we are going to summate moment at point A is equal to 0, taking the clockwise direction as positive, we assume that the moment at A is directed counterclockwise. So this is negative moment in A. And the moment to be created by this resultant na WOL over 2 will be clockwise, no? Kasi pababa siya, so dito tayo nagmo-moment, iikot siya ng clockwise. So that would be positive. So positive W sub OL over 2. And that would be multiplied by the moment arm. The moment arm is the distance perpendicular, no? From the point dito sa point A kung saan tayo nagmo-moment at doon sa resultant, which is the L over 3. So we have here L over 3. And this is equal to 0. Now, computing for the value of the moment at A, then we have here W sub O L squared 2 times 3, that's 6. Okay? And since we have here the positive moment, so meaning we have the correct assumption, since our assumption, the moment at A is directed counterclockwise at positive yung lumabas, then tama siya na counterclockwise. And this is now the value of the moment at A, which is equal to W sub O L squared over 6. Okay? So it's time for us now to draw the shear and moment diagram. So in drawing the shear and moment diagram, so let's start with the shear. As you can see here from our previous computation, our shear diagram here starts with AY. The AY is WOL over 2, no? Directed upward. So aakyat siya.
Sir, nawala po yung share screen po.
Oh, sorry. So we have here WOL over 2. Ito yun. So this is WOL over 2. Yun yung magnitude ng shear natin dito. Now, we are going to subtract our resultant, no, ng load natin, which is WOL over 2 then. So, WOL over 2 minus WOL over 2, that would be equal to 0. So, magsi-0 na siya dito. Ngayon, kung titingnan natin, galing dito sa may point na to, siya ay W sub O. At pagdating naman dito sa point na to, siya ay 0 na. No? So, meaning, our load is decreasing. So, if we are going to review our dYIX, since our load is decreasing, then we are going to apply this dy. No? Since decreasing siya, magbe-bend tayo ng y-axis later. Okay? So, paano natin gagawin? Kung makikita natin dito, ito yung scenario natin. Nandito si WOL over 2, nandito naman yung 0. So, ibig sabihin, our next point is at quadrant 4, and this point here is our origin. So, ito yung y-axis natin, ito naman yung x-axis natin. Okay? So, since decreasing siya, magbe-bend tayo ng y-axis. So, itong y ang i-bend natin. So, magiging ganito yung kanyang mukha. Kasi po, yung y-axis yung binend natin. So, therefore, this is our diagram. So, to drawing natin ang ating diagram, so yan, nag-bend tayo ng ating y-axis. And this is our shear diagram. And as you can see here, we have the degree 1 in our node. So, meaning this is degree 2 curve na pagdating dito sa ating shear diagram. So, pupunta tayo sa moment diagram natin. For the moment diagram here, makikita natin that we have the WOL square over 6 counterclockwise for the moment of A. So, bababa tayo ng ganyang magnitude. So, we have here negative WOL square over 6. Ayan. Pagkatapos, kailangan kumpitin natin yung ating area sa shear diagram. Papangalanan ko siyang area 1. Okay? So, computing for the value of the area 1. Area 1 is just a spandrel. No? It's 1/3 base times height. Kasi kung parabola yan, it's 2/3. So, computing for that, we have area 1 is equal to 1/3. The base is equal to L, and the height is equal to WOL over 2. Ito po yung height na to, yung magnitude ng shear natin. So, we have here, area 1 is equal to WOL square over 6. And it's positive, no? Since positive yung area natin sa area 1. So, it's negative WOL square over 6 plus WOL square over 6. That would give you 0. So, magsi-0 na tayo dito. Ngayon, titingnan natin. Yung ating shear diagram dito ay may magnitude na WOL over 2. Pagdating natin dito sa point B natin ay 0 na siya. So, meaning decreasing pa rin siya. No? Decreasing. Okay. Pero ito yung scenario natin. Yung scenario po natin, nandito siya si negative WOL square over 6. Ito yung point natin tinutukoy ko. And this point B here ay nandito siya. So, always yung point na nasa left, yung i-consider natin na origin. So, ito yung x-axis ngayon, ito naman yung ating y-axis. Ngayon, since decreasing siya, so dy ang gagamitin natin, mag-bend tayo ng y-axis. So, kung i-bend natin yung y-axis, ito po siya. Yan. So, ito yung magiging mukha ng moment diagram. So, kung gagawin natin yan, we would have here this. Okay? So, ito na ngayon yung ating moment diagram na kung saan siya ay merong negative na area.
Sir, yung about po sa fourth example po, yung naka-highlight po ng yellow po sa taas. Ano po yun siya? Given na po yan siya?
Hindi po. You have to compute po yan. Kasi po, yan ay resultant ng load. So, since triangle ito, ang resultant niya ay area ng triangle. That's 1/2 base times height. 1/2, yung base niya ay L, yung height niya ay W sub O. Pero, yung decision kung saan mo siya ilalagay ay nakadepende sa location ng centroid. So, since triangle siya, doon mo siya ilalagay sa 1/3, 2/3. 1/3 galing sa 90 degree, tapos 2/3 naman galing din sa 90 degree part. Kaya, hindi ka pwedeng magkamali ng paglalagyan ng resultant. Kapag yan ay rectangular, katulad nito, doon natin siya nilalagay sa midspan, kalahati. Kasi nasa kalahati yung centroid. Pero kapag triangle yan, doon mo siya ilalagay sa 1/3. Okay tayo doon?
Okay po, sir. Thank you po.
I-emphasize natin yung yung bending. Kasi hindi natin na-emphasize yung bending. Kasi one of your objective is to have the intuition on the bending, no? Ano ba yung magiging elastic deformation? So, ang magiging basis po natin dito is this. Since dito ay negative moment, ano kasi to? Kumbaga, 'di ba, sinabi ko doon na kapag yan ay positive moment, no? Kung ikaw ay nakaalala ng positive moment, so sa kahit kaninong tao man yan, sigurado na ikaw ay ngingiti. Pero kapag nakaalala ka ng mga negative na moment, sigurado na ikaw ay manulungkot. At itong mga symbol na to ay tumutukoy, no, doon sa bending natin. So, pag positive moment, this would be the bending. Pag negative moment, this would be the bending. Okay? So, since negative moment ito, the bending would be like this. Since ito ay fixed connection, mag-i-straight mo na yan sa part dito. Kumbaga, mag-straight mo na yun siya dito bago yun siya bababa. Bababa. Yan. So, kapag kinargahan na ng load, this would be the bend. Pagdating po natin ang chapter 8. Chapter 8 ba? Anong chapter naman tayo ngayon? Chapter 4, chapter 5, chapter 6, 7. Oh, yes. Pagdating natin ng chapter 7, ay wait, ano pala kayo? Oo, tama, meron tayo nun. Kinukomplete naman natin to, deformation. Gaano kalaki yung deformation niya? Given is the load. No? So, ito yung magiging bending niya kapag meron tayong ganitong load. Because it's negative moment. Kumbaga, ito yan siya, oh. Negative yung moment mo, nag-bend siya, itong kalahati. Kumbaga, kung kalahati nung ngiti ka, nasag ka kalahating part lang. Parang stroke lang. No, ito yung nagsag. Ito yan. Okay. Tingnan natin to. As you can see here, we have the positive moment. So, since positive yung moment natin dito, the positive moment will tend you to smile. You have to smile with the positive moment. So, ibig sabihin po, ang nature ng bending natin dito is this. No? Medyo straight muna dyan. Tapos, aangat siya dito. Ba't siya umangat? Dahil dun kay moment, release siya ng para counterclockwise. Kaya, nakaangat yung bending nito. Okay? And here, you also have negative moment. So, since negative moment, diba? Pag negative yung moment, malungkot yan. So, yung bending natin dito would be yan, like this. And the same with this, since negative din yung moment natin dyan, so ibig sabihin yung bending natin ay ganito. Okay?